As an example of the magnetic field due to a wire, current in a wire, we have this problem. Two long wires are oriented so that they are perpendicular to each other. At their closest, they are 20 centimeters apart, and we want to know the magnitude of the magnetic field at a point midway between them. The top one is at 20 amps and the bottom is at 12 amps. Well, let's look at our direction of our magnetic field. And so in the case of the top wire, the current's coming out at us, so using the right hand rule, I have a current going counterclockwise, which means that at this point, this field is pointing to the right. And for the bottom wire, if I put my right hand rule, thumb going with a current, this current is going in the counterclockwise direction, and this vector is coming out of the screen. And these two are going to be perpendicular to each other. So we can write a formula for the top. So our magnetic field in the top is going to equal mu naught times the current of the top divided by 2 pi times the distance from the top to the bottom, or to the midpoint here. And that's going to be in the I direction. And our magnetic field for the bottom is going to be mu naught I bottom over 2 pi R bottom. And that's going to be in the J direction. So our net want to put net there so we know what we're talking about. Is just going to be equal to the square root of B top squared plus the magnitude of B bottom squared and get a little more paper room here. And so that's just going to be equal to square root of mu naught I top over 2 pi R top squared plus mu naught I bottom over 2 pi R bottom. And that's squared. And we have to square root everything. But I know that R top and R bottom are equal because it's the halfway point. So I can factor out. This is going to be mu naught mu naught over 2 pi R top, and I'm going to have a mu naught 2 pi over R top, and both of those are going to be squared, and then I'm going to take a square root. So I can pull this out of the square root, and then I'm just going to have the square root of I top squared plus I bottom squared. And that's equal to 4 pi times 10 to the minus 7th Tesla meters per amp over 2 pi times 0.01 meters. Or no, that's 1 centimeter, and we're doing 10 centimeters, so it's 0.1. Times the square root of 20 amps squared plus 12 amps squared. And I calculate that out, and I get that it is equal to 4.665 times 10 to the minus 5th Teslas. So a very small magnetic field based on the currents that are going through the wire.